And here's the filter that I would like to measure, connected between the two ports. This is an exceptionally high quality factor filter. It has 15 stages connected, so you expect a huge rejection out of band. The center frequency of this is around 3 gigahertz. So if we go ahead and measure this, this is what it's going to look like. And take a look at that. I mean, this is a huge drop. We're looking at a minus 120 dB. I've turned off the averaging. Note that we're using an IF bandwidth of 100 hertz. That, of course, slows down the instrument significantly. And if you look carefully, you should be able to see it sweep across. So that averaging is going to take, obviously, some time. Now I can go ahead and turn on the averaging as well. You can see it going through. So it is quite slow at this, which is normal. And we're going to turn on its averaging. I'm going to let it run for a little bit longer. That's going to push this in another 10 or 15 dB down. And we can really see if there are any imperfections at all from this filter. And here it is after the averaging is completed, and something very subtle emerges. If you look over here, we do have a tiny response from this filter sitting at this frequency, which was a little bit invisible before the averaging. This is a very difficult measurement to make because you're trying to resolve something 120 dB down while the noise is around it, and this allows you to push the noise down, which is quite nice. Let's put some markers on this. We can add a marker here, and we can take this marker and put it over here, and we can see that this is around 1.8 gigahertz, and we can add another marker, and we can take that marker and move it across as well. It's reasonably easy to use. Oh, I moved the first one again by mistake. Here it is. Look at that. So we're looking at about half the frequency. It's to be expected. This filter is not going to be perfect at multiple of its center frequencies. This is a 3.6 gigahertz filter, and there's probably something at 7.2 gigahertz too. It's just that outside of our frequency of measurement. This is quite good, and means that you should be able to measure these extraordinary high dynamic ranges relatively easily.